Hello kids, hope you all are in good health. Today we are going to talk about bases.
So, so let us start with our topic bases. What are bases? In chemistry, bases are the substances that in aqueous solution releases hydroxide OH negative ion, are slippery to touch, can taste bitter if an alkali, change the color of indicator, for example, turns red litmus paper to blue, react with acids to form salts, promote certain chemical reactions like base catalysis, accept protons from any proton donor or contain completely or partially displaceable OH negative ions. Examples of bases are hydroxides of the alkali metals and the alkaline earth metals. For example, sodium hydroxide and calcium hydroxide, etc.
Now we have classification of bases. First one is classification of bases according to strength, means degree of ionization. What is this ionization? It is the process by which atom or molecule acquire negative or positive charge by gaining or losing electron, often in conjugation with other chemical chains. The resulting electrically charged atom or molecule is called an ion. Based on the strength, we have two types of bases. One is strong base and other one is weak base. Strong bases. Strong bases are those bases which are completely ionized in the water. Means when we dissolve the base in the water, they completely break down into positive and negative charge. Their solutions are good conductors of electricity. They are considered as strong electrolytes. For example, potassium hydroxide, sodium hydroxide, barium hydroxide. Now, weak bases. Weak bases are those bases which are incompletely ionized in water. Their solutions are bad conductors of electricity. They are considered as weak electrolytes. For example, ammonium hydroxide. Now, on the basis of acidity, first, the acidity of a base depends on the number of hydroxyl ions it contains. It also depends on the number of hydrogen ion with which a base can combine, as one hydrogen ion combines with one hydroxyl ion. It's usually of three types: monoacidic base, diacidic base, and triacidic base. First type is monoacidic base on the basis of acidity. Monoacidic base is a base that consists only one hydroxyl ion and only combines with one hydrogen ion. For example, NaOH, KOH, NH4OH, etc. For example, when a reaction between NaOH and HCl takes place, it gives us NaCl and water. Now, diacidic base. It is the base that consists two hydroxyl ions and combines with two hydrogen ions. For example, magnesium hydroxide, iron hydroxide, and zinc hydroxide, etc. For example, when a reaction takes place between CaOH2 aqueous plus 2HCl, it gives us CaCl2 aqueous plus 2 times H2O. It's our liquid. Now, triacidic base. It is a base that has 3 hydroxyl ions and combines with 3 hydrogen ions. For example, are aluminum hydroxide. reaction between AlOH3 aqueous plus 3HCl. It gives us AlCl3 plus 3 times H2O. Third one is based on concentration. The concentration of the base depends upon the amount of base dissolved in water. It's of two types, concentrated and dilute base. What is concentrated base? First one, concentrated base. What is the concentrated base? If the percentage of the base in aqueous solution is high, the base is known as concentrated base. For example, concentrated sodium hydroxide, concentrated potassium hydroxide, concentrated ammonium hydroxide. Or we can say if the amount of the water added to it is less as compared to the base. Now dilute base. Dilute base is opposite of concentrated base here if the percentage of base is low in aqueous solution, or we can say if the water added here is large as compared to the base. For example, dilute sodium hydroxide, dilute potassium hydroxide, dilute ammonium hydroxide, etc. Now we have reaction of bases. First reaction of base is with metals. When base reacts with metals, it produces salt and hydrogen gas. We can write general reaction for this. When a base reacts with metal, base and metal is our reactant. It gives us salt and hydrogen in product, or we can say the product will be salt and hydrogen. This general reaction will help you to remember that when a base combines with metal, it always gives us salt and hydrogen. Few examples are given here. I will try to explain the reaction. First reaction is between base, which is sodium hydroxide, and metal, aluminum is here. When the both combines, they give us sodium aluminate and hydrogen gas. When we perform this in a lab, we will understand there what actually happens here. But unfortunately, we are not able to do this time. We will do it definitely in lab. Our second reaction is between sodium hydroxide and metal zinc. When reaction takes place, it gives a sodium zincate and hydrogen gas is evolved here. In first reaction, water is added in reactants. Our sodium hydroxide is basically in solid form. To make the aqueous solution, we are using this water. That's why water is written here. Now, our second reaction is between the base and oxides of non-metal. Non-metallic oxides are basically acidic in nature. For example, our carbon dioxide is non-metallic oxide. When carbon dioxide, when we dissolve it in water, it produces carbonic acid. Therefore, when a base reacts with non-metal oxide, both neutralizing each other, resulting respective salt and water are produced. Remember, always remember the general reactions. Like for this, our general reaction is base plus non-metal oxide. It gives us salt and water. Few examples are here. First one is reaction between calcium hydroxide. Calcium hydroxide is our base, and between carbon dioxide. Carbon dioxide is our metal. When reaction takes place between the two, it gives us calcium carbonate and water. Calcium carbonate is salt and H2O is water here. Now, second example is reaction between sodium hydroxide, which is our base, and again carbon dioxide, which is our non-metal. When the reaction takes place, it gives a salt, sodium carbonate, and water. We have uses of bases. We use bases in our everyday life. I will discuss few here, like our sodium fluoride. We automatically feel the first base of our day after brushing our teeth. Toothpaste, which we mostly use, contains sodium fluoride, which is slightly basic in nature. Sodium hydroxide. Every day we take a bath, but water all alone is not enough to make us feel refreshed. We use soap to clean our body, and these soaps contain sodium hydroxide as their main ingredient, which is our base. Sodium bicarbonate. Sodium bicarbonate, commonly known as baking soda, is the regular kitchen item. People use baking soda in cooking, baking cakes. Being a weak base, it is safe for human consumption. Magnesium hydroxide. Magnesium hydroxide is the compounds that are used as antacid or for neutralizing the gastric acids. Our calcium hydroxide, commonly referred to as hydrated or slaked lime. It is widely used in cement manufacturing. Ammonia. Ammonia is one of the widely used base in agriculture, industries, and homes. It is one of the ingredients of fertilizers. It is also used in eliminating stains and tarnishes of soaps from tubs, tiles, floors, and even jewelry. After uses of bases, we will move to our next reaction. The reaction is neutralization reaction. Neutralization reaction is a reaction in which an acid neutralizes a base when they react with each other. In reaction, salt and water is formed. General reaction is when acid combines with base, it gives us salt and water. Here we can see an acid and base both neutralizes each other, hence the reaction is known as neutralization reaction. Few examples are here between acid and base. Look at the first example. First example is between sulfuric acid and sodium hydroxide base. When the both combines with one another, they form sulfuric acid. They form sodium sulfate and water. We have more reactions here. Look at the reactions first. Reaction between nitric acid HNO3 and sodium hydroxide. It gives a sodium nitrate NaNO3 plus water. Our HCl, when it combines with NaOH, it gives us NaCl plus water. HCl plus calcium hydroxide, which is our base, when the both combines, they form calcium chloride and water. We can use one word here. We can say neutralization reaction are also known as double displacement reaction. What happens in double displacement reaction? Simply the exchange of ions takes place. Look at the reaction which is between H2SO4 and NaOH. When we check the reaction, our H2 is positive, SO4 is negative. In base, Na is positive, OH is negative. What's going on here? Our H2, which is positive, it reacts with OH, which is negative in base. They both combine and form water. SO4, which is negative, and Na positive of base, they both combine and form our sulfuric acid. Form our sodium sulfate. Simply the exchange of ions takes place here. That's why I said neutralization reaction is also known as double displacement reaction. Now, reaction of acid with metal oxides. Metal oxides are basic in nature, like our magnesium oxide, aluminum oxide. When an acid reacts with metal oxide, both neutralizing each other, in this reaction, our salt and water is formed, like in our neutralization reaction. Example: calcium is a metal, thus calcium oxide is metallic oxide, which is basic in nature. When an acid, such as hydrochloric acid, reacts with calcium oxide, neutralization takes place and calcium chloride along with water is formed. Our acid HCl plus calcium oxide CaO, which is basic in nature, when they combine with one another, they form calcium chloride and water. Calcium chloride is salt and water as byproduct. Similarly, when sulfuric acid, when it combines with zinc oxide, it gives us zinc chloride and water. When hydrochloric acid reacts with aluminum oxide, aluminum chloride and water are formed. Now we have reaction between metal oxides and bases. As everyone knows, metal oxides are generally basic in nature, so when they react with base, no change will occur. Hope you all understand today's topic. Thank you. Stay safe.